John, and just want to say thank you again to the organizers for inviting me to be here. People have been gathering throughout history. I mean, we're ultimately social creatures, but mass gatherings really are a function of the fact that there are 7 billion of us on the planet, but every 12 years we add another billion people, and we have this amazing piece of technology that allows us to cross vast distances in short periods of time. When we think about those factors together, increasing the world's population, opportunities for movement, and the fact that we're social creatures, this is really what results in mass gatherings. I'm going to be talking a little bit about the whole movement and how people tend to behave in terms of their travel behaviors globally during mass gatherings, using data that my colleagues and I have been working with now for about 10 years or so, looking at commercial data from the global airline industry. So, given this is a fairly short presentation, I'm going to just talk about 2 particular things. I want to talk a little bit about global travel patterns observed during the past Summer Olympic Games, looking back from Sydney in 2000, and Athens and Beijing, and then London, and then possibly, what might this mean? Is there any inferences that we could make in terms of what might happen in 2016 in Rio? And not just in terms of the volumes of travel. We heard in one of the earlier presentations this morning that when you have an event like the Olympics, some people really, really want to go there, and some people really want to stay as far away as they possibly can. How does this play out in the mix? Do we have a net huge increase? Does it tend to be neutral? And also, where are people coming from? Are there different sources of where people are originating from? Are they sort of changing, or they follow typical seasonal patterns? And can we use that information to make certain decisions when it comes to planning for, preparing for potential infectious disease risks in the host city of a mass gathering? And then the second part I'll just talk a little bit about is some work that we had the privilege of working with the Health Protection Agency in the UK. Ryan McCloskey's name came up earlier this morning, working with Ryan, who is playing a lead role in preparedness for public health risks during the Olympics in London, was on how we can start to think about connecting global information and surveillance, understanding global mobility, and then local context at the host city, and trying to use that to support some decision-making, potentially decision-making that is very time-sensitive. So what I'm going to actually just do is jump right into the data, and I'm just going to start to show you some analysis of data from airport statistics and worldwide passenger flight itinerary data that will give us some ideas as to how people have tended to move during the Olympic Games, and has there been a really substantial surge in international arrivals. Now I want to point out this is only looking at commercial air traffic. There may be other mechanisms that people or other modalities people are using to get to Summer Olympic Games, but this will give you some idea of sort of the big, vast distance type of travel. Now on the y-axis we have is monthly international arrivals and departures, and what you can see here is this is the pattern of travel into Sydney, and if we look at the time period when the Olympics was happening in Sydney, you can see that it's just roughly in around 400,000. I've actually made this highlight a little bit to show just the month before and the month after, so you get a sense of when people might be coming and going. Now if we compare this to the year after, you can see that there's a bit of a decline. It's in the order of around 75 to 100,000 travelers. So this gives us a little bit of a sense as to how big of a surge is there in terms of volumes of individuals coming into the city during one of these types of events. Again, we may have millions of tickets sold, we may have lots of visitors, but as we heard earlier, some people, some of the more traditional tourists, or people perhaps coming for business or visiting friends and relatives, they might decide to stay away. So what actually happens in the city? And we can see in the case of Sydney, it was a fairly modest increase of around 100,000 people. Now if you're wondering what that was, just a little further to the right, there are a lot of interesting things that you can find by looking at how people move. This big decline in 2003 was a result of the SARS outbreak. And if we fast forward to 2004, looking at the Athens Games, what you see here is a very, very consistent pattern in terms of travel. And you probably also are noticing that there isn't really any big obvious spikes. And so this is when actually the games were happening in Athens. Now I do understand that there were more individuals coming to this Olympic Games by sea than there were at other games. But if you do look at this, this actually sort of turned out to be more or less in a wash. It didn't actually seem to have any net increase or net decrease in travel compared to other years that you can see adjacent to that time frame. Now I found 2008, the Beijing Games, to be particularly interesting because if you look at 2008 and you see the time frame where the Olympics occurred, and you look the year before, it's actually lower in terms of the total numbers of travelers that are arriving. And these are international travelers. And initially we were kind of uncertain as to whether this actually was a real phenomenon. And we have been using multiple different data sets. This data set is looking at passenger ticket sales for commercial flights. And we also work with and use airport level statistics data, and have found exactly the same findings here, that in Beijing in 2008, the actual volume of travelers compared to what would be normally expected for that time of year was lower than was observed. Just of interest, this is right after the Olympics. The Lehman Brothers declare bankruptcy, and you can see this whole strange pattern, disruption to movement that's not only observed in China, but in many other parts of the world in 2009. It's kind of as though the world skips a few beats in terms of its heartbeats here, and then sort of recalibrates a couple of years later. Now, when we actually take a look at this using a time series analysis, this is an ARIMA model, an autoregressive integrated moving average model. Basically, we're trying to fit these data to see how consistent they are, and then what we're doing is we're just plotting the residuals, how much of a deviation from what we would normally expect is being observed in each month. So the values that are above this line here, ones that are above the line are ones where there was a little bit more travel than we would have otherwise expected. Ones that are below the line are ones that are a little bit lower than we would have expected. And really most of the stuff in the middle here is just sort of random variation. If we take a look at the period where the Olympic Games occurred in Beijing, again, you can actually see here, there's just a very modest increase in one of the months, but really the net amount of flow into the city is actually lower than would normally be expected. So just moving ahead to the London Games, again, you see a very kind of harmonic type of signature here. And it doesn't appear, looking at this in 2012, comparing to the year before and the year after, it actually is slightly blunted in terms of international air traffic volumes. And we actually, so again, performed a time series analysis on this. Took a look here in terms of where the London Games took place, and you can see it kind of just plays out more or less in this main area here, which is the central area, is kind of more or less what you would expect at that particular time of year. So I think this can be useful perspective in terms of what are we going to be dealing with in terms of the scale of the gathering. Often we're talking about millions of visitors, but it also may be that millions of visitors may not be coming as well at the same time frame. This drop there down at the bottom, I can't unfortunately pronounce that, but this is the eruption of the volcano in Iceland that resulted in a significant decrease in international travel between North America and Europe in particular. And so what I'm kind of highlighting here is there's lots of interesting knowledge that can be gleaned by looking at how people are moving and what the behaviors are, sort of more from a global collective perspective. So another question that kind of comes up as well is when we're dealing with mass gatherings, do we have people coming from very different parts of the world compared to where they would normally be coming from in the non-Olympic year? And so with this year, we just plotted out on the y-axis the number of international arrivals coming in August in 2008, and on the x-axis we have the international arrivals coming in August of 2007. So we're just sort of comparing how does one year relative to the other. And this blue line is just the line of best fit, and it just shows that in general there is a fair amount of consistency, and each one of these dots, I should point out, is a country or a subset of a country. And so what we can kind of see here is there isn't, huge deviations in terms of numbers by countries. If we were to look at this and sort of square this chart off, 1-to-1, where the y-axis and the x-axis are perfectly aligned, anything above this white line would mean these are more travelers in the year of the Olympics compared to the year prior to the Olympics, and anything below would mean that these would be lower numbers than were observed in the year of the Olympics. So what we can see here is in 2008, Hong Kong had about an additional 10,000 travelers coming into Beijing. Presumably, some of them were interested in the games, and in other areas of the world, we actually had a decrease. Relatively speaking, people perhaps may have decided they wanted to stay away from the city during the games, and this is what we see. But more or less, you can see that there's a fairly consistent pattern, no major deviations in terms of where people are coming from. This was actually also quite consistent with what was observed in 2012 when we look at the London Olympic Games, a very tight fit here, and looking at this squared off 1-to-1, comparing the year prior to the Olympics and the year of the Olympics, it aligned actually quite closely. Working with Brian McCloskey at the Health Protection Agency, he had later confirmed that the ticket sales data that they were working with were very consistent with the actual usual origins of travelers into London. I think 90% or so were coming from Europe, and then there were a handful coming from other regions of the world, very consistent with the usual patterns of travel into London for this time of year. So I'm going to just shift gears a little bit, picking up on the earlier presentation and I suspect John's presentation. This is a little bit of a discussion of the framework of how we were working with Public Health England during the Olympics, and sort of thinking about how we might be able to collect and organize and integrate information from different sources to support better planning and response to potential infectious disease risks. So on one hand, this is a perspective of looking at infectious disease risks globally, finding their way into the host city of a mass gathering. I'm not talking about it in this presentation, but there's also the other side of the coin, which is people who may acquire infections locally and take it back with them to their home country. But in this instance here, by integrating information in terms of pathogen activity, using surveillance data, whether it's usual patterns of notifiable disease surveillance, or looking at endemic diseases, whether it's looking at event-based surveillance or informal sources of data for surveillance that can be very timely. Once we have that type of information, being able to sort of integrate that with an understanding or an assessment of how we would expect people moving from around the world into the host city of a mass gathering. And then really, this pathogen receptivity is really to identify that infectious diseases are moving all the time, but they don't necessarily have a big impact. If you have one case of cholera that comes into the city in the United States, it's probably not going to go very far because it doesn't have the right environment. If one case of cholera goes into Haiti, for example, after an earthquake, it's a very different kind of impact, a very different kind of outcome. And so integrating all of these different components, thinking about what's happening globally, what's happening in terms of movements, and then what do we know about receptivity? It might be the presence of an insect vector, it might be a suitable climate for a vector-borne disease to be active, and so on and so forth. So by integrating this type of information, we can perhaps better plan and respond to infectious disease risks. So now I'm just going to show you a 10-15 second animation of how we were looking at travel into London over a 5-year period. So I've shown some temporal analysis, I've shown some spatial analysis, and I'm just going to show an animation that links both the spatial and the temporal pieces together, and you'll see over 5 years how people move into London. So the base of this map is actually each one of these periods where the blue moves back and forth is a season. The temperature is on the base map, and then you can see the heights of the bars rising and falling. That's New York over in the left side over here, you can see most of this travel into London is coming from parts of Western Europe, but you get a sense of where people are coming from. And using this kind of approach, and then working with John Brownstein here, working with the European CDC and Public Health England, we were then looking at how we could kind of structure and organize this type of information and couple it with upstream surveillance data. By the way, these call-outs here are just hypotheticals, they're not real events, but it gives you a sense that, if there was a case of naturally occurring plague in New Mexico, it helps put into perspective that the level of connection from this location into London is quite weak. But you have a disease like mumps, which is highly contagious. We know we've been seeing a resurgence of mumps in many parts of the world. We know that immunity in parts of the UK is suboptimal in people who are sort of in their 30 to 40 year old range. And so mumps may be a very, very important thing in terms of upstream disease, connection, and then local susceptibility in a gathering which is going to be very densely populated and crowded. So what can we perhaps glean from this in terms of 2016? What might things look like in Rio? I'm just going to show a little bit around how Rio has changed in terms of its footprint, in terms of global air travel. In 2000, this is what the flight lines look like in Rio. In 2015, you can see how it's actually changed. There's been a significant growth in terms of flight connections to different areas of the world. And you can actually see this in terms of flows over the last decade in terms of looking over in 2005, each month there used to be roughly about 100,000 international arrivals. Looking now to the present, we're roughly double that number, about 200,000. And if you see that spike over on the far right-hand side, that's actually coinciding with the time of the World Cup. And this is when the period of the Summer Games is going to occur. Obviously, we haven't mapped out to 2016, but it's actually not coinciding with the usual period of peak travel into Rio. That actually tends to occur in around February or March when Carnival is happening. So this again may give you a little bit of some insights, possibly, at least from the perspective of international air travel, when the Olympics is going to occur, and based on some of the experiences of the previous games, what might we expect? Again, with each one of these events, as you can see, they are a little bit unique, they are different. Beijing had a decrease in travel, for example. Sydney had an increase in travel. And this is something that we're just continuing to try and learn from and understand in terms of travel behaviors. So if we're looking at the origins of travelers coming into Rio in August, and we're looking at the national level, we can see the areas that are in darker blue are places where there are larger numbers of travelers. If we look at that at the city level, we can actually start to glean this in a little bit more detail. And this is where coupling this with information on global disease surveillance can be useful to get a sense. Is there some important public health event happening in a place where there's a lot of movement coming in, or is it in a place where there's very little movement and perhaps the risks of translocation would be lower? So just to summarize and wrap up here, I think some of the key messages that I just wanted to share is that at least looking at international air travel, the recent summer games going back to 2000 are really only associated with a fairly modest, and I'm going to say net change in international air traffic flows. Certainly we know that there are lots of people coming in, but there are also probably lots of people who are deciding they're going to postpone and actually come maybe at a later point in time. The global spatial distribution of inbound air travelers for many of these games, I just showed two of them, Beijing and London, just for time reasons, but they tend to follow the pattern of where people are usually coming from. People tend to buy tickets and presumably come to the games in ways that are consistent with the usual flows of people from that particular geography. I think, if we actually aren't seeing huge increases in this type of event, I want to highlight that different types of mass gatherings are very different. Religious gatherings like the Kumbh Mela or the Hajj, those are very, very different. But if we're looking at something like the Olympic Games, it may be that the net size of the population isn't all that different, but it's really the local population dynamics that have changed in terms of behaviors and activity of individuals. So that may be one of the most important public health issues. Nonetheless, given that this is essentially you're hosting a party for the world, you obviously want this to go well, and you don't want an infectious disease outbreak to be, part of that story. There's some really interesting opportunities, I think, to be integrating global information in near real time on infectious disease events and potential outbreaks, gathering that information quickly, whereas traditional surveillance might be too slow, given that these types of events are usually only in the order of maybe a few weeks. Integrating that with an understanding of people's movements and behaviors at a global scale, and then understanding what that means in a local context, and using that, again, for planning purposes and, if need be, for public health response to infectious disease events in the host city itself. So I'll end here and just thank you very much for having me here today.